So what I'd like to do here is I'd like to do a review of what we did last time with motion diagrams. Okay, and so what we said here is that we had two ways of changing velocity. Either I could have a constant velocity or a change in velocity. If I had a constant velocity, what happened here is that I had constant speed and constant direction. So you could see here is that if I'm looking at my dots here are closely spaced together. And so my arrow then is going to be short, which I draw with the small v. And you could see here that it says slow speed. And again, they're all headed in the east direction. And you could see here is that the reason why it's slow here is because the displacement is very tiny between the dots. And even though the flashes are occurring at the same interval, we have a smaller v. So therefore, my velocity is a slow speed going east. On the other hand, if I have a fast speed, you could see that the dots are farther apart, and as a consequence, I drew a longer arrow and a larger v. In this case, what happens is that, what do I have? What I have here is that you could see is that I have a larger displacements between the dots, same amount of time, therefore I have a larger v. Fast speed going east. Now let's talk about changing velocity. When I change velocity, there's two ways to change it. The first way, I could be changing the speed while holding the direction constant. So what you're seeing here is that as I change velocity, you could see that the dots are getting farther apart. That means that the displacements are getting larger and larger. As a consequence, you could see here that my V's are increasing in size, just like my arrows are increasing in size. So therefore, I'm speeding up while driving straight. In this case, I'm driving in the east direction. On the other hand, if my dots are getting closer together, and you could see that between 0 and 1, that's 4 squares, then the second square, the third dot is 3 squares, and then the fourth dot is 2 squares. So what you're seeing here is that the spacing is smaller, therefore my displacement is smaller, so therefore the speed has to decrease. And then the final dot, I'm assuming here that it has come to a stop. So therefore, I'm slowing down while driving straight. In this case, driving to the east. Finally, let's talk about changing speed here. If I change speed while holding direction, while changing the direction, this is what we call turning. So in this case, what we're seeing here is that if I look at all of the spacings of the dots, I try to draw them so that they have equal spacings. Therefore, it has a constant speed. So initially, I am driving east, but now what happens is I start to make a right-hand turn. So I have to change the direction of the steering wheel. So you could see that the arrows are starting to change direction. And so I'm driving east, and then my arrows finally at the end point south. So I have changed directions. So now what we want to do is that we want to start the new lecture here. And this new lecture is going to be lecture 1.2, and it's going to be motion diagrams continued and unit conversions. When we look at unit conversions, you'll see I'll have to define a little bit more about speed because we need to mathematically calculate. Now, again, where am I getting all of these examples? Right out of that lecture and example page. Okay, I'm getting a lot of emails of where this is located, and you just got to get onto Canvas. And if you get onto Canvas, you're going to see one of the tabs that says lecture and examples. Each module, each chapter has it. Okay, so we want to continue with motion diagrams. So let's look at this guy here. It says example 1.1. I want to draw a motion diagram. Let's shoot for about 10 dots. Doesn't have to be exactly 10. but somewhere in that number. For each motion described below, and identify regions of constant or changing velocities using dashed vertical lines across your diagram. Now note that I have two contradictory statements. It says for each diagram, use 5 to 10 dots to indicate the motion clearly. Well, 5 to 10 seems more realistic. Okay, so let's look at the first one here. It says a rocket-powered car on a test track accelerates from rest to a high speed and then coasts at constant speed after running out of fuel. Okay, so here we go. So we know that the key word here is that it's going to be doing what? It accelerates from rest. And then what's going to happen? It's going to coast at constant speed. What we have to do here is that we have to identify those two intervals. Why is it so important? Because when we go to problem solving, that's what we need to be setting up. So here we go. So what I'm going to do here is that I'm going to say that right here at 0, I'm going to say that right here, we're going to start from rest. And now we're going to accelerate. So what you want to be paying attention to as we look at this, we have to look at the size of the arrow as we move from changing velocity to constant velocity. That's the tricky part. Those are the intervals here. So here we go. So the first thing that I'm going to do is that I'm going to draw my first dot. And then when I go to my second dot, I'm going to space it out farther. So what you're seeing here is that my interval is getting larger. Then I'm going to go to my third dot, and here I go. Right here, I'm going to identify that this is where the fuel runs out. So now here comes the question. What do my arrows look like? So at 0, if I start at rest, there's nothing there. But now let's say that at point 1, my arrow is 1 square. At point 2, because I am speeding up, my arrow gets longer right here. So what I'm seeing here is my arrows are increasing in size, which then tells me that right in here, I am speeding up. So that's my interval right there, right? This is my interval. This is telling me that I am speeding up. Now, here's my question. At point 3, is my arrow the same size? Is it longer? Or is it shorter? And the way we answer the question is we look at the intervals. Look at the interval. The interval from here to here is that size. Then I look at the next interval. The interval from here to here, that's 2 squares. And then if I look at this interval, you could see that this interval is even longer. So therefore, my velocity at 3 has to be larger. So now I see here that my speed is higher. Now, because it runs out of fuel, it's now going to move at constant speed. So now I'm going to come in here and I'm going to say, this is my interval of constant velocity. Why constant velocity? Because it's moving straight. Now, look at the dots here. So the dots from 2 to 3 were 3. So now my dots, I'm going to say, are going to be 4. So then after that, my speed does not change. So therefore, my arrows are going to be the same length. And that shows constant velocity. Now, if you were mathematically solving this, so mathematically solving this problem, two intervals require two sets of equations. In other words, if I look at this interval number 1, and then I look at this interval number 2, this picture then tells me how to set up my equations. That's why the picture is so important. Okay? That's why the picture is so important. Now, let's go to the next question. So I'm going to do the exact same question. And let me go here, and let me grab that. So if I go to that example, this is part B of that question. Now I'm going to make this a little bit smaller and a little bit taller. I'm going to distort the words a little bit, but I'm hoping that it just reads cleaner. So B, a bowling ball being returned from the pin area to the bowler starts out rolling at constant speed, then it goes up a ramp and exit onto a level section at very low speed. So how do I want to look at this picture? The way I want to look at this picture is that it says it has to go up a ramp. So what I would do here in this situation is that I would try to draw a ramp and just look at this as one-dimensional motion all the way along. So here I go. So I'm going to say that let's look at what they're actually telling us. So it says it's returning and it's rolling at constant speed. Then what happens? It goes up a ramp. So what do we know when a ball goes up a ramp? It's got to slow down. And then it hits a level section. And a level section, we know that it has to slow down because it went up the ramp. So I need to include 3 intervals from this. So here I go. So here's my flat space. And then I'm going to say that then it's going to go up a ramp. And then it's going to go through this flat place here. Okay. So here we go. Now, I don't know how to set up my arrows here. All I know is that it's moving at constant speed. So what am I going to do here? I'm actually going to put an arrow right here. I mean, a dot right here. Then I'm going to put a dot here, and I'm going to put a dot here, and I'm going to put a dot here. This is where I'm going to call my 0, but the ball's already moving at constant velocity, but I need the previous interval to tell me what's happening to the ball, the speed at 0.1. So here I go. So the first thing that I'm going to see here is that I know that the ball is moving. Now look at my previous interval. All of these intervals are going to be the same. So I'm going to say that these guys all have the same length here. Now we can clearly see here is that this is where the ball is going to go up the ramp. Okay. So this is where it goes up the ramp. Now we gotta be careful here, but the ball is still on flat ground. So the question that I have, what is the speed at point 3? Is it going the same speed? Is it slowing down? We know that it surely can't be speeding up if it's going to go up the ramp. And how do I answer that question? Look at the interval. If this is the length of my interval here, and then this is the length of my interval here, you could see that the interval is the same. So now what has to happen? At point 3, this thing has to have the same speed. Let me draw this more parallel. So these 3 arrows are supposed to be the same length. Now it gets tricky here. So here I go. Now this thing is going to slow down. Okay. After this, I want to be careful. You know, I'm going to put my dot right here because I need to have a dot right there when I get to the very top. So here I go. So if that's 3 squares, I'm going to try to make that smaller. And then I'm going to try to make that smaller here again. So I'm going to play it by ear. So let me see here. So now what happens? As it moves, this is 0.4 right here. So now my arrow has changed length. So now my arrow has to be smaller than the previous. Progress. Okay. So if it's smaller, what am I actually seeing here? That means then my arrow has to be even smaller here. And this is going to be 3. And you can see here is that this is getting smaller and smaller. And you know what? I'm going to have to change my track. Okay, so I'm going to change my track because otherwise that ball's going to stop. So I said 3, but it should have been 5. So let me change the length of this to make it work. So then my next dot is going to be right here. So right here is going to be my dot 7. Now I'm going to push my dot right here. So in this interval, we said we had constant velocity. Here, we're slowing down while going up the ramp. And then that says the level section, I'm going to assume that it has constant velocity. So now, what do I do here? When I get to here, here's my question. When I get to, you know, that's a 5, not a 6. Okay, so this is 5. This is 6. This is 6 up here. So what should my speed be between, if I compare between 5 and 6, is my arrow going to be longer, shorter, or the same? In this case, I have to again draw my arrows, my interval. look at this interval. This is this interval right here. This interval is smaller. Because it's smaller, then my arrow has to be smaller. So then, because of this, now it's going to move at a slow speed as it goes. So you can see here is that now this moves at a slow, constant speed. So if I start to bring in my arrows, I'm going to say that this is the size of this arrow. They're all trying to be the same. Now, these guys are getting smaller, smaller, and then really small. And then they stay the same size the whole way. Again, look how I'm separating the intervals. So this one's tricky because, there's a lot of dots that have to go in here. Now let me go get the next one. And this is the last of the motion diagrams that we want to look at. I'm gonna decrease again this way, and I'm gonna increase it that way and distort it. Okay, it says a car is parked on a hill. The brakes fail, and the car rolls down the hill with an every increasing speed. At the bottom of the hill, it runs into a thick hedge and gently comes to a halt. Okay. So when I look at this, what am I seeing here? If the brakes fail, we can see that it rolls down the hill. And as it rolls down the hill, we know that it's going to be speeding up. But then it hits a hedge, right? It runs into a thick hedge and gently comes to a stop. So what I'm seeing here is that there are two intervals here. So what am I going to do? I'm going to try to draw my motion diagram to represent the motion that we actually see here. So I would think about putting an angle to this guy. And so I'm just going to draw a straight line just as a guide for me. And so I'm going to say that right here is this incline that I'm thinking about. Okay, so what I'm going to do here is that I'm just using that as a guide here and not anything else. So here I go. Here's my first dot. My first dot is 0. And we know that right here that this is at rest. The car is at rest. Okay, so the car starts off at rest. Now the car starts to accelerate. So then I'm seeing my dot, then I'm seeing another dot, and then I'm seeing even a larger dot here. Now, as I'm looking at this thing, what speeds am I seeing? Well, I'm seeing that my speed is increasing. So I'm seeing that my arrow is getting faster and faster and faster. And then what I'm going to say here is that right here, it hits the thick hedge. Okay. So here's one. Maybe I should write it up here because I want to look at my intervals. So then the question comes to, what is the size of my vector at point 3? Is it the same size? Is it longer or is it smaller? Well, here we saw that it was speeding up. And then here we know that it has to slow down. And stop. So here I go. Look at the interval. If I look at this interval, that's small. If I look at this interval, and then if I look at this interval, you could see that the interval between 2 and 3 is longer. So therefore, that arrow has to be longer. So it's moving at a faster speed at 3 compared to 2. Now it starts to slow down. So as it slows down, then if I look at the interval between 2 and 3, it has to be smaller than the interval between 3 and 4. So then here I go. Here's going to be my 4 interval. So my 4 interval now says that in this interval, it's going to be slower. And then in this interval, 5, it's going to be, it's even going to be smaller. And at some point, let's say at 6, right here, we're going to say that right here it stops. So you're seeing how I'm trying to draw these motion diagrams right here. So this is what I'm hoping that you really practice a lot on your homework,